Today we're going to be talking about ordinary differential equations. Differential equations are everywhere. They're used to model anything from the growth of bacteria in a test tube to the nature of flashing fireflies to the orbits of planets around the sun. To begin, it's important for us to learn and understand what a differential equation means. A differential equation contains one or several derivatives of an unknown function. Differential equations can be divided into two different subsections, with the first one being ordinary differential equations, which involves one or more ordinary derivatives of unknown functions. As you can see here, it's d squared y over dx squared plus 6xy equals 1, whereas for a partial differential equation, it involves one or more partial derivatives of unknown functions, as denoted here by delta. In this video, we will be discussing, and particularly on ordinary differential equations, which involve one or more ordinary derivatives of unknown functions with respect to one independent variable. As you can see here, d squared y over dx squared minus 5 dy over dx, x is the independent variable, plus 2y, where yx is the unknown function, equals to a cosine of x. Order of ODEs is essentially just the order of the highest order derivative. For our first example, we can see here dy over dx minus y equals e to the power of x, where it is a first order ODE because there's only one differential present. Our second example can show us that it is a second order ODE because the highest order in this equation is d2y over dx squared. Our third example is the same thing because there's no higher power compared to d2y over dx squared, hence it's a second order ODE. Solutions of ODE is a solution to a differential equation is a function that satisfies the equation. What this means is general solutions dy over dx equals 2x, and so after we integrate the equation, it will give us y equals x squared plus c. Whereas for a particular solution, dy over dx equals 2x, it's given an initial condition of y when x is 0, y equals -1. Hence, after we integrate the equation, we will get y equals x squared plus c, y equals x squared minus 1. Notations used are the Leibniz and the Lagrange prime notation. Now we will dive into demonstration for the first order ODE.
Now let us do some example on first order ordinary differential equations. So example 1, the question is y prime minus y equal to e to x. As it is a standard form, so we can know that px equal to -1 and qx equal to e to x. Let us plug in the px and qx into the integrating factor. So yx will become e negative integrate -1 dx bracket integrate x multiply e to x dx plus c. So after simplify, it will become ex bracket integrate e minus x e to x dx plus c. After that, after integrate, it will become ex bracket ex plus c. The final answer will become cex plus e to x. Now let us do another example. The question is xy prime plus 4y equal to 2x cubed. Since it is not a standard form, we need to divide x for each term in the equation. So it will become y prime plus 4y over x equal to 2x squared. So now it become a standard form, and we can know that px equal to 4 over x and qx will become 2x squared. Okay, let us do a integrate factor, which is ix equal to e integrate px dx. So it will become e integrate 4 over x dx and become e 4 ln x. 4 can bring to the behind and it will become e ln x power to 4, and e and ln can eliminate and the final answer will become x4. Now let us plug in the x4 into the integrating factor. It will become yx equal to 1 over x4 bracket integrate x4 multiply 2x squared dx plus c. Let us simplify it. It will become 1 over x4 bracket 2 integrate x power of 6 dx plus c. After integrating, it will become 1 over x4 bracket 2 x power to 7 over 7 plus c. So the final answer will become 2x7, 2x power of 7 divided by 7x to power 4 plus c over x to power 4.
Now moving on to the second order ODE demonstration.
How to solve this question? From the question, we know that d squared minus 3d plus 2x is equal to 0, where d is equal to d over dt. After that, we can know orthogonal equation is m squared minus 3m plus 2 is equal to 0. Then we need to solve the equation. After solving the equation, we can get m is equal to 1 and also m is equal to 2. After that, we will get the complementary function, which is equal to a e power of t plus b e power to 2t. Also, the generation solution will be processed out, which is x is equal to a e power of t plus b e power to 2t. That's all for this question. How to solve this equation? From the given equation, the equation is d2y over dx2 minus 4 dy dx plus 5y is equal to 0. From the equation given by question, we can know d squared minus 4d plus 5y is equal to 0. Then we need to know the auxiliary equation. The auxiliary equation is m squared minus 4m plus 5 is equal to 0. After that, we can use completing the square to solve the equation. After the equation is solved by completing the square, we can get m minus 2 is equal to plus minus square root 1. And the final answer will be m is equal to 2 plus minus I. It is if the form alpha plus minus I beta. After that, we can get the complementary function, which is e power of 2x a cos x plus b sin x. So the generation function is y is equal to e power of 2x a cos x plus b sin x. That's all for this question.
To summarize, in this video, we've explored the basics of ordinary differential equations, focusing on first and second order ODEs. We've also covered that differential equations are formed by two, firstly ODE, and the second being a PDE, partial differential equation. ODEs are crucial in modeling and solving a wide range of problems in science and engineering. For example, we have here this gravitational acceleration graph, and they can also be used to solve real-world examples such as population growth, RC circuits, Newton's law of cooling, and also simple harmonic motion. we encourage everyone to delve deeper into differential equations and discover more about the fascinating properties of their applications. Thanks for watching, and we hope to see you in the next video.